Welcome back, Munchers. Today we're going to cover the 5 magical properties an algorithm should have. An algorithm, as we've defined it, is a set of instructions in a certain order which solves a problem. Now, there is a slight clarification I have to make here. You might be confused because that sounds like the definition of a program. However, algorithms are not programs. Programs exist to run the algorithms by implementing them in code. This means algorithms themselves aren't based in any specific language, but we will be implementing them in Java as programs in the future so that we can test them. If you haven't seen the introduction video to this channel, I encourage you to check that out in the description below to get a better idea of upcoming topics and things you should know. Now, getting back to the topic. Based on how we understand recipes, they have a format behind them generally. Recipes have a list of ingredients and their quantities listed at the top. Then, they have a numbered list of ordered instructions to carry out. If things weren't listed this way, the recipe could get chaotic. Similarly, algorithms have their own set of 5 properties for that reason too. So how do we know an algorithm when we see one? Let's take an example of one of the simplest algorithms that already exists. This algorithm returns the sum of 2 numbers. Well, first, what does the algorithm require? You have to give it 2 numbers so that it can run, right? In fact, every algorithm needs something you have to provide, called an input. But wait. What if you have an algorithm that only returns the word hello? You don't need to give that any input, right? Yes, you're technically right. An algorithm can have 0 or more inputs, but for a large number of problems that are solved in your programs, you should pretty much always have an input. Alright, after you give the algorithm the 2 numbers, it has to return the sum. This is called an output. Every algorithm needs to return an output. Whether you see it on the screen or not, an output is not optional. You can return multiple outputs, but at least one is required. Another requirement is that algorithms have to stop. Imagine if you had a recipe that said, mix all the ingredients together forever. Nobody would make that dish because it can't be done. In other words, every algorithm must have what we call finiteness. If you write a program with an algorithm, the program shouldn't run with no end in sight. What else? Well, people tend to think that computers are amazing machines that can solve anything. But that's not exactly true, is it? A computer program runs an algorithm based on how we write it, so the steps performed have to be known by us. All algorithms are clear, and we call this definiteness. For example, you can't input a question like, "What's the meaning of the universe?" and expect the computer to give you an answer. The computer doesn't know any more than carrying out the set of tasks you give it, just at a faster pace than you would do by hand. If we go back to the original algorithm, returning the sum of 2 numbers, this is finite because the program has an end when it returns a sum. It's also definite because there's clarity to what's being asked. The result of 2 numbers have to be added together and returned. Finally, there's one last aspect of algorithms that might sound silly but needs to be said. The algorithm should be effective. That means you can't be writing statements that have no purpose in the algorithm. Just like a recipe wouldn't say, water the plants in the middle of making spaghetti, everything you include in an algorithm has to have a good reason for being included. To summarize, there are 5 key elements every algorithm should have: 0 or more inputs, 1 or more outputs, finiteness, definiteness, and effectiveness. Hope that helped. Comment down below on what you think is your favorite of the 5 properties we learned today. Otherwise, thanks for watching. If you liked what you saw here, give it a thumbs up, share it with your friends, subscribe, and hit the notification bell so that you know when the next one's coming. I've recently opened a Discord server for people interested in discussion that you can check out. See you next time.